this way. Okay? Pick a number. Hold on. 1 second. You mean small? You mean smaller, like number line smaller this way, leftwards, right? You want a number to the left of your -1 value. Is that correct? So -3.
Yeah.
-3 is kind of far away.
-2.
Okay, that's a little bit closer. So if you pretend for a second, if you put -2 in here, what does it evaluate to? What is f of, just to get an idea of what's happening, what's an f of -2 in this case? You'll crush that with your mind. Come on. What is that? What is it?
3.
3. 3. So it turns out, over here at -2, if we go up to 1, 2, 3, it's up here. So what does that tell me? Maybe it's shooting down here. Maybe it's going to go like that. Maybe it's going up like this. I don't know. What's it doing? Yeah.
Doesn't have to shoot upward because there's only 1 0.
Does that shoot upward? Why? Because
It has 1 0.
it only has 1, 0. Ah, very good. This thing cannot travel downwards because there's only 1, 0 here. And this is how you figure it out in pre-calculus a lot of times. Figure it out by the logic behind knowing how many zeros you have and locations around the asymptote. And now I want to analyze it from a limit perspective. So I want you to think about what is happening as you get very close. I'll just write it here since you were correct. I have it going up there. Okay. So what's happening is you get very close to -1 from the left. You want to be able to think this way. Look at this expression here. This is what we're talking about, right? Replace this here. X minus 1, replace it with the function symbols. There. So these x's here are getting very close to -1 from the left of -1. So they are more negative than -1. You follow so far?
Okay.
Every value that this x considers right now is more negative than -1. And it's never going to be -1, right? X is never going to reach -1 from the left. So therefore, it's always more negative than -1. You with me? This is going to decide whether it's up or down. This logic right now. So as you're putting in numbers which are really close to -1, but more negative than it, the bottom is getting close to what? 0. The entire time the bottom is getting close to 0, is it positive or negative?
Negative.
Negative. Because you're putting in values which are more negative than -1. So something which is more negative than -1 added to 1 is still a tiny bit of a negative. Yeah?
The same thing happened at the top.
Okay.
So it would be 2 negative to make that positive.
Exactly. So the bottom is always negative when we consider the limit from the left-hand side. Right? And the top is exactly what you just said. Since this is something more negative than -1, okay, it's negative. With another negative tacked onto it is still negative. Therefore, the top is always negative regarding this limit. This limit, the numerator is always negative. This limit, the denominator is always negative. But the bottom's heading towards 0. And the top's heading towards non-zero. So therefore, it's heading towards an infinity. Which infinity is it? Negative divided by negative is, so therefore it's positive infinity. Okay? And that was a lot of explanation. But if you think about it like that just a few times, it'll come pretty quick, right? Because you don't want to graph this. You don't want to find the zeros and think about the relationship between zeros and asymptotes. You just want to be able to think this way and knock out what the infinite limit is, right? Let's analyze it from the other side. X is approaching -1 from the right with the exact same function. So now we have a number which is, all these x's, are they positive or negative? They're still negative. Remember that when you talk about limits, you're talking about a very tiny window around your location. So you're not really approaching from over here on the positive side, heading close to that -1. You're approaching from very close to the -1. As a matter of fact, no matter how close this line would get to 0, your approach is always negative, right? You can always find some small window in there that you're only considering negative x values. Yeah?
The negative has to be smaller than the positive one on the bottom. That's always going to be a positive one. It's never reaching -1.
With the top?
It's not, the top would be a negative plus negative. So it would be negative infinity?
That's right. You got it.
And since it has that x-intercept, it has to be negative infinity, right? So it has to go through, to the bottom. Yeah.
No, it could have done like this. You didn't know. You didn't know.
Go like that.
Wait, what? Can you explain that?
Which part?
The
That
part
whole
goes.
last part.
The whole last part was, since we are now heading to -1 from the right of -1, right? X is heading this way. All the values for x are still negative, because we're only talking about a small window, really, around the point of concern. So here we are with our little x values here, heading towards -1. So that means every x that we're considering here is negative, but it's not as negative as -1. So therefore, the 1 down here overpowers it. I'm adding 1, right? If I take a number that's in here and I add 1 to it, it makes it positive, correct? So as I approach this value from the right, the denominator is always positive. But the top, since x is always negative in this consideration, because I'm very close to -1 here, x is always negative, adding another negative keeps it negative. So we have a negative over a positive the entire time this limit's being taken. But the bottom is still heading towards 0. That's a fact for both these limits. The bottom's heading towards 0. But it's never going to be 0, right? So you should never think that the sign down here is irrelevant. It's never going to be 0. It's just getting really close. And all the time the bottom's heading towards 0, the denominator is positive the whole time. So since the top is heading towards -2 ultimately, which is non-zero, and the bottom's heading towards 0, that's an infinity. Which infinity is it? I look at the signs. The top is negative, the bottom is positive. So therefore it's always a negative ratio here. So it's negative infinity. So that means the graph must be trucking down here, and we might have thought, if we hadn't analyzed it this way, that perhaps it was coming down here. Perhaps it shoots up and goes back down here and goes this way.
Okay.
I didn't know until I took the limit, right? It's a very, there's no algebra to really do here, right? You have to think like this. There's no algebraic games like we did last time. You're not going to remove any common factors. You're not going to play any conjugate games. You have to be able to think about where you are as regards what you're heading towards. Am I to the left of it, to the right of it? Am I dealing with negative numbers? How does that influence the values in here? All right, and be able to think like that. Let's try another one. Make sense so far, though? What we're trying to do, at least. Not at all. All right. Determine the following limits or state that they do not exist. Number